Okay, so we're looking at the Eclipse developer environment for Java. And in this section, we're going to take a look at how we can interact with the SQLite database. And this is a file-based database system. So similar to Microsoft Access in the original days of MDB files, this does not require a network. It does not require a TCP/IP port because it's not the client-server multi-tier architecture that SQL Server utilizes. So this is a reliable, fast way to store data locally on the mobile phone. And then we can detect a Wi-Fi connection when we return to an office or a Starbucks coffee or some other location that has free Wi-Fi, and then take advantage of the high-speed bandwidth to synchronize content in the local SQLite with the database itself. So we're looking at the Eclipse developer environment. Let's get started with a new project. So File, New, Project. We're building an Android project, so we'll click that for the wizard. The new Android project wizard pops up. And we'll follow the same nomenclature, the pattern that we've been using lately here as appdev_Android and then SQLite. That'll be the project name, followed by the type of name that we have. This is a project. So every time we see the word project show up, we remember where this came from. So again, we can target a common platform, level 4 API. And also we'll come back to looking at the honeycomb stuff on level 12 in a different section. So we're looking at the Android open source code plus the Google corporate APIs that includes things like maps. We have the application name. We'll call it appdev Android SQLite and then application. And we have a package name. So the website address backwards, com.appdev. So this is your company name's website, followed by the project name or the package name or something like that. So we have an application, a package, we need an activity, the min SDK version. We can skip step number 2 and just go right to the end. And that gives us the blank project under the Project Explorer window. Here's SQLite. Here's the Java class file. That's the user interface. Remember that under Visual Basic we would call this a form. But here under Android it's called an activity because it has some other attributes in addition to the standard UI attributes. The generated files have not yet been created. We could see the reference to the standard Android stuff. Under assets, we're not using any assets yet, but just as a footnote, the assets folder is a good place to store stuff that includes like HTML files. If we wanted to make an HTML5 application and store all the HTML locally, we could do that. So under resources, we have the graphic files, the drawable, high, low, medium resolution. The layout files, that's the markup language, and the values, the strings file. So let's start by editing one line here. We'll add 3 asterisks. We'll stop. Let's save this, and we'll set up a run configuration. So Eclipse is flexible, can do a lot of different things, but what we'd like it to do is take this project and send it to a mobile phone, either through the USB port or to an emulator. So we'll set up a run configuration. We'll give it a name. And the project is the SQLite project. We'll launch this manually. We'll have it prompt us for which emulator to start. And since there are none running, we'll launch one. Okay, so now the status bar notes are complete. The SD card has been initialized. We'll hit page up. That brings us to the desktop of the mobile phone. And this is the app. So app dev, Android, SQLite application, and the message has the 3 asterisks. Hello world, app dev, Android, SQLite activity. So this is the user interface. Now in this example we're taking a look at the database, SQLite. And we'd like to be able to create the database structure first. And also we'd like to insert new records into the tables that we'll have to create and insert content into. And when we create a table, remember that we're defining the structure, so the names of columns and the data types of columns. So the way that we're going to do that is by utilizing a new feature, a plugin that we can download for free that works with the Firefox internet browser. So this is what it looks like. Basically, after installing Firefox, we could do a Google search on SQLite plugin for Firefox, and the download is very easy to find and easy to locate from the Firefox website. So what happens is that the SQLite Manager becomes one of the tools off the Tools menu in Firefox. And this is what we get when we open up that tool. And this is one database that's already been created. And the structure here for the one table that's in the database is this table right here. So create table, table name, column names. This is basically the declarative statement. Remember that within a SQL environment we have different categories of vocabulary. We have the data manipulation components that are things like insert a record, delete a record, update a record, read a record. But we also have these other meta tags that allow us to create the structure within the SQL database itself, like things like create table. So within this tool, we can look at the structure of the database. We can browse the current content. So there's one record that's added. We can actually execute content as well. So let's test this out. So we have insert into the values, and let's just add something. We'll put a percentage or a decimal place after this 0.1 on all of these. Okay, so add a new record that has 3 columns, longitude, latitude, altitude, with the values 123.1, 456.1, 789.1. We'll hit run. No error occurred, so let's see if it actually worked. Browse and search. There we go, we have a second record. So basically this is a nice tool because like Microsoft SQL Server, this is like using one of the SQL Server management tools that gives us the data structure here on the left, and it lets us interact with this without typing in the like Telnet window, the Query Analyzer window, to interact with that. This is a nice visual way to look at that content. So we have the sample records. What we want to do is to ask the question, how do we do this from an Android mobile app? How do we insert content into the database? So we have 3 records. We added 2 just a moment ago, and we want to figure out the best way to insert records onto a SQL database that lives on the mobile phone. And there are a couple different paths that we have available to make this happen. So first of all, we could execute raw SQL, just like what we see here on the screen. But a better way is to use something like under ADO.NET, the concept of parameterized objects. So we call a store procedure and we pass in parameters, or we invoke an SQL statement and we have a parameterized query. And the reason why it's a better idea to not pass parameters on a text string in SQL is because of the problem with the escape sequences. It would be very simple to break an application by inserting an apostrophe using the possessive use of the apostrophe, like Robert or Roberts apostrophe S. So the apostrophe S is like a string terminator. It would break up the sentence right in the middle of the sentence. So the way that we get around that is by avoiding using raw SQL from any multi-tier client-server application. And what we do is on the user interface layer, rather than executing raw SQL to the backend, or if this is a middle-tier business object, rather than executing raw SQL into the backend, what we're going to do is to set up some of these database objects that are part of Android API. And using the content values objects, we're going to pass in parameters. and basically mirror the same concept of the command object in Visual Studio for Microsoft. So now that we know the basic idea of where we're headed, we have a intention to create a database in the mobile phone. This particular database is sitting on the desktop of the Windows 7 system here, but we want to mimic the exact same behavior within the mobile phone. And then when we're finished, one thing that we can do is we can actually peek into the mobile phone's storage mechanism, both the SD card and also the internal memory. We can actually download the SQLite database from the phone back onto our PC and come back into this application and study the output. So we could grab a copy of the database and look at it right here in this window. So before we toggle back over into the Eclipse developer environment and build the application over there, looking at the structure here, one of the nice things about this tool is that it's very simple to use to build new tables. So for example, if we highlight the table object here and we just say new table, we're going to add this to the main database, not the temp database. Let's give it a name. We can call it AppDev, Android, SQLite, GPS table. So that'll be the object name. We'll give it 3 columns, longitude, latitude. And if we don't remember the data types, we could pick them from the list. And basically these are interesting suggestions under SQLite. Unlike Microsoft SQL Server that may actually store the binary data based on this value, SQLite stores all its stuff as text content. So this actually helps for formatting purposes and also for mathematical calculations, but the actual disk storage doesn't get affected by our choice here of data type. So, okay, this is the statement that will get created. And if we put it on the clipboard, we could actually borrow that and use it over inside of Eclipse. So let's do that. Let's flip over to the Eclipse developer environment. We have our blank project. And the way that we can use this is we could take this text string, and rather than trying to place it inside of the code, the Java code, it could get really, really messy. To do that, we would have to escape out all these quotes with the backslash using the C notation, and we don't have to. So what we can do though is just to say string name equals, let's do the same convention, AppDev, Android, SQL, create table. The application that we write, the first time that we run it, it will detect whether or not the database, the SQLite DB file, has already been created and whether or not it has the content that we need. And if it's empty, if it doesn't have a database file, this string then will be something that we call on one time to create it, but we don't call it a second time. But we do have to have it in there for the first time that we call the database create. So we're going to reference a string, and this is the string's name. We could come in here and make changes to this if we wanted to make updates. This would be the place where we would do that. So we just used the plugin under Firefox called the SQLite Manager. This is a free tool. Firefox is also a free tool, just like Eclipse is a free tool. And this is going to be code that we fire off one time, and actually it's the only time that we need to fire raw SQL anytime that we use database access with SQLite under Android, because the Android data objects are a little bit easier to use than raw SQL. So now that we have this, let's go ahead and save it. Let's go back over into the Project Explorer window, and under the .java file here, let's add some code that will test that we actually have the right create table syntax. So let's log file that content, log.i. The create table value is going to come from somewhere. So what we're going to do is to utilize that string. And the way that we get that string is we could do a couple of different things. We want to get a reference to the current context. We're going to get a string from r dot, and there's the recently created string value that we're looking for. Okay, so the definition of a log file is undefined. Let's bring that in. Create a table, and this is the magic command. Let's save it, and let's test this out. Okay, so here we go. This is the create table value that we're looking for. And this is the content that we created using the tool in the Firefox plugin, the SQLite Manager. So now what we want to do then is to write the code that creates from scratch a new database. And if we run the code a second and a third time, all we want to do is to open an existing database. But the first time around, we like it to create the database from scratch and create the objects like the tables from scratch as well. So that's going to be the step that we take a look at next. So now let's take a look at how we can use an object provided from the Android platform called the SQLite Open Helper. So when we create this new object, we're going to create a class nested inside of a class, and this is how it works. So rather than defining another function, like here we have public void and then function name, what we're going to do is to set up a new embedded class. And we don't do this very often, but it works really well in this context, so we're not going to use it anywhere else except for right here within this class. So we're going to create a class, public class, and we're going to call it something. And basically it's a SQLite Open Helper, SQLite Open Helper 1. So we're going to create this class to do a thing, and it's going to extend the base stuff that we get with SQLite Open Helper. So the definition of SQLite Open Helper is undefined, so we bring in the definition of that, and we should be able to find that at the top of the screen. SQLite Open Helper dot SQLite dot database dot Android. So we need to add a constructor, and this is the requirement of that constructor, and it's a little bit complex. So there's a context object, there's also a string name, a cursor factory, and an integer version. Now integer version is something that we could talk about right now and get it out of the way. So let's say that we create a database, and it almost is very similar to the status bar notification window where we create our own ID. Well, basically under the version number here, we create our own version numbers, and let's just say that we start with 1. Well, let's say that a year goes by and we decide to make a change to the structure, maybe add a column to the table that we're working with. So we call that version 2. And so the value of having this feature within SQLite is that the application can open up a very, very old version of SQLite. It can look at the content of it. It could detect the fact that some of the content in there is very useful, but it's not the most up-to-date version of the structure. So code can be written to actually create and generate the new table structures, copy the data over into those, compensate for the missing data by default values, and so on. It's a really simple solution to a very common problem. And so basically this version number is something that we could set as 1, and throughout this whole course we could leave it as 1, and it would work just fine. But then down the road in a year or 2 years we might change that to 2 or 3. So we have the SQL Open Helper number 1, and to make this a little bit more easy to read, we break these out. On separate lines. So here we go. We have this public constructor, which is almost like calling a method. It has the expectation of arguments. And so we need to be able to pass in things like a context, a string name, the name of the database. So it's like a file name. We could call it mysuperduper-database.db or something like that. The cursor factory, the reference to the version, and that should work just fine. So the next step in this example is to add our first function to this new class that we're creating called SQL Open Helper 1. And the thing that we need to do is to add a function that will manage the creation of a new database. So we could say something like this. We're going to override the definition of the base class defined here in SQL Open Helper. Let's see, we've got a little red arrow here. Okay, so that's what we're doing right now. We have to implement these two functions, the onUpgrade and also the onCreate. And this is the code that we're actually in the middle of typing. So we're going to override this. So public void onCreate, and there's a SQLite database that gets passed in as a parameter here. We'll just call it DB. Also, let's bring in the definition of what that is. So here we go. Database, SQLite, database Android, also the cursor factory, database. So there's one more minimum function that we need here is the, in fact we could override one more, public void onUpgrade. So this is that hypothetical down the road a year from now. We might add a table, drop a table, change a column, add a column. And this is the code that we would then implement to fulfill the process of converting or upgrading the actual data file itself. But it may never actually get called. It may never actually get updated. So some of the parameters, the SQLite database. Also, two integers. So the logic would say, given the following facts, this would be like taking a case to the Supreme Court, not knowing anything about what's going on except just these facts. If we knew the version that was in the file on the mobile phone that we're currently running this on, if we knew that version, and if we were given the current version, the most recent version, we would write the logic then that would fix everything to make it all good. But we'll just put return because we're expecting to make one database that doesn't have an update. But we need to have the stub there just to satisfy the expectations of the class itself. So when the onCreate happens, what are we going to do? We want to have it build the database that we've defined here using the strings XML that we actually figured out using this tool here, which is a SQLite Manager tool that generated SQLite specific SQL to make that happy. So when we look at the application now, we want to grab this content right here and make that the statement that gets fired off. So how do we make that happen? We want to reference the content of the SQL just like we did here. This dot get string, and then this string is the string that we're looking for. So this is something we'll probably recycle. So to start, let's just make sure that we could still reference the context of the strings XML. So notice this little error right here that says that the method getString is undefined. And this is a really big deal because basically what it's saying is that this call to getString was only valid within the immediate reference to this currently running activity. And not just that, when we instantiate this instance of the SQLite Open Helper, we're calling it S04E05, when the onCreate fires, we don't actually control that. And so we just write the code that responds to that event. We don't know what thread it's on, what process it's on. We don't really have much control over any of that. But we still want to be able to access that string. The getString method is not in focus. It's not in context. It's like not even a global variable. It's like a local variable somewhere else. So one way that we can get around that is by setting up a parameter that we can then pass in the reference to that activity. And once we have that activity, we can then use it again so that we can replace this with the activity. So for example, let's just say A1 is that activity that has a getString, and let's just say that A1, when it's done, will point to the same context that represents this. Now, the way that we can make that happen is by setting up another parameter in the constructor that says that also pass in an activity that we'll call A1. And in the class itself, let's put a hidden version of that, like a member variable A1 as data type or object type activity. So here we go. We have this activity called A1. It's equal to nothing. When we instantiate and get this A1, and we do a lot of setup work here, we'll add our own setup work. We'll say refresh the secret A1 and make it equal to this pointer to this. What that will really mean is that we want to know a reference to the memory space, the pointer to this version of this. Store it right here so that we can reference it here as underscore A1, and the red squiggly goes away. So it's all like magic. We basically are able to capture that reference to that activity when we need it. So now we want to create the instance of a SQLite Open Helper, passing in the A1 on top of all this other stuff as well. So how does that work? We're going to create this new instance. Let's set it up as a global. And the instance here that we're going to create is going to be not the exact original, but it's actually going to be one of these. So it's a modified version of the Android class library. So we'll call it just my S04E05, trying to keep that simple. So we'll set that equal to a new instance of this. Passing in the parameters. So the first question is the context. What is the context of the application when it runs? The next question is the string for the name of the database. The cursor factory is optional. We can actually use a null. The version, we're going to use 1 all the time, and the activity is going to be a reference to this. All right, so here we go. The first parameter on our S04E05, that's our SQLite Open Helper number 1, which is the modifications that we've made that allow us to manage the creation of the database table by using the strings XML. So the first parameter wants to know more about the application's runtime. So we'll pass in this get application context as the first argument. The second parameter that we're going to pass in is the name of the database file itself. So we could call this appdev Android SQLite.db. We can name it whatever we want to name it. The third parameter here. So we have a context, file name, cursor factory can be null. We don't, at this point, we don't need to pass in our cursor. So the version number will be 1 and the activity will be this, and we'll close that off with a semicolon. So up to this point, if we can execute this code without crashing anything, we could be happy that the code works, and then we can add more additional code that'll insert records into that database file. So let's do that. Let's add a little note here that says the onCreate function has reached the end. And also that it's reached the beginning. So we have a begin and end that we can send out. So in the next step, what we'll plan on doing is to execute this and hope that the onCreate method can compile and run without generating any error messages. So let's hit go. That actually is very good. No error messages so far. The log file. On create, beginning and ending. Also the text for the create as well. So there's a 99% chance that all is well. The database file got created. Now what we want to do is to prove that by adding additional code that can insert database records. And then we'll confirm the content by taking a look at that database file and see if there's anything in it after we're finished loading our data. So far in this example, in the onCreate function, we're creating a new instance of a database. And the process basically goes through creating a new file if it doesn't already exist, but calling the same application function again and again and again. It'll recognize the file is there. As long as the version is matching, version 1, then we can move on to the next step. And that next step is to insert database records. So the way that this works is that we're going to utilize 2 more objects. We're going to utilize a writable database object called the SQLite database. And also, to manage all these values, we're going to use the content values object. And this is like under Visual Studio working with the command object. It's the same concept, just a different name. So let's give this a try. We're going to add a SQLite database, and we could just call this DB. And this is going to be equal to something. So remember that the open handler, the my SQLite open helper, is basically managing the potential complexities of upgrading versions of the data source. So we'll call on this, and we'll say get a readable or a writable database. So a readable database would be for read only, and that's nice because it's not going to have access to locking file. But writable database is the only way that we can insert new records. So once we have this database, another thing that we need is the content values. This is like a command object. So we'll say content values CV is equal to something. Now the definition of content values, we need to bring that in. So we import content values.content.android. So content values is equal to a new instance of. So a couple of things are going to happen. First of all, we're going to package up the content through this content values. Then we're going to execute through the database the update. So remember that over in the SQLite environment, we talked about creating this new table. And the longitude, the latitude, the altitude, those are the columns that we wanted to create. And the way that we implemented that is by utilizing the strings XML to store that same content that we created over there in the Firefox tool. And since the open helper should already automatically be able to create that table statement for us. That's the mechanism here. We can assume that it's there. Hopefully it's there. We got no error messages, so we're going to move forward as if it's all working properly. So content values dot put, and then there's a key value pair for each of the columns. So for example, we have the longitude, and we can start these values off at 1. So I'll put 123.1. Four, 5, 6.1. And 789.1. All right, so this is the content that we want to send into the database. This is our handle to the database with record locking capacity. So we're getting really close to having this work and be a real database. So what we're going to do next is we're going to invoke a command on the database that says insert or throw. So throw an exception in Java if something goes wrong. Basically it says insert the record or crash the application, because we're not going to add error handling at this point. So insert or throw. The name of the database table. So we created this table called AppDev Android SQLite GPS table. Let's copy that. And the next step is to basically bypass this. We'll just put null because we don't need to worry about that question. And the values parameter is what we have right here. Okay, so let's stop. Let's save this. Let's hit go. And we did actually manage to crash the application, so we'll have to fix that. So the application, AppDev SQLite, stopped. Please try again. So we'll say close, and we'll go back and debug this. So we can follow the stack trace. We're looking at the logcat, and we're looking at the red stuff, because basically the red stuff is what traces back the problem. So we could see that the onCreate was successful. We could see that the create table content is there. It looks good. So let's go through the logic here in the red. No such table. So there's a table name, a spelling problem, or something of that sort. So let's take a look at what might cause a problem with the table name. Remember that down below we have this child class, S04E05, the SQL Open Helper, and one of the purposes of this class is to create all the table objects when this function gets called. And up to this point we could see correctly logging the name of the table in the SQL statement, but not actually firing it. So let's add that one line of code. So the way that this works is we reference the database handle. This is coming in as a parameter, the argument here, as the DB1 is our handle to the SQLite database that's in play here. So we want to say something like this, db1 dot, and then do something to create that table. And the way that we do that is by firing off a SQL statement that creates the table structure. So we could say db1.execute a SQL string. And the SQL string that we're trying to execute is this content that we already checked. And we know it's right. So that looks good. And we can add additional log entries now that would basically say on create, and we could say begin. Begin and end, and we can tack this in here as well. And now that we're theoretically making a change to the file, we might also have to change the version number as well. But we'll try this first, and if it doesn't work, that means that we're going to have to actually bump this to version 2 so that the system will trigger on create again. Because the problem is that we've run this once without any errors, and that may or may not work now because we have a file. It'll see that file, and as long as the versions haven't changed, it's going to assume that the file is the right structure, but we've just added an object into it, so that might give us a good reason to bump this up by 1. So if this runs and it crashes, then we're going to have to bump the version number. If it runs and it doesn't crash, then all is well. So go. And we have a version problem, so we're going to come back and we're going to say we want to open up, and we're going to basically upgrade this. So version 2, now we have a reason to fire off the upgrade code. And we'll try this out. So that looks better. We didn't crash the application. So the assumption then is that the database now has the object. The assumption also is that we executed an insert statement, and that also didn't create an error. But in order to see this content, what we can do is to extract this file, bring it back out of the emulator. Remember, the emulator is basically identical to a phone that was plugged into the USB port. It's really not considered part of the PC that we're developing on. But we could go through the ADB debugging tool for Android. We can say pull out one file that we need. We could place it on the desktop. We can open up the SQLite Manager under Firefox and tell it that we have a new database that's sitting on the desktop, and we want to know what's in that database. So that's the next step, is to take a look at the content inside that database file just to confirm that everything that we've done so far worked exactly like we expected it to work. So one way that we can test the content of our SQL database is by using the Firefox plugin for SQLite. And basically what this is going to do is to allow us to open up a connection to a database file. So this file is sitting on the desktop, appdev, Android, SQLite3.SQLite. But the file that we want to look at is sitting in the internal memory of the phone. It could be a USB connection to a real phone, or it could be a phone that's running as an emulator, and it's actually no different from our perspective. So what we have to do is to drop down into the command prompt and go get that data inside the phone. And there's a tool that we can use inside the Android SDK. So wherever you install the SDK, look for this folder called Platform Tools. So there's this file called adb.exe. That's the Android debugger file. And if we say something like this, we could say adb shell, and this gives us access to the hard drive inside the phone. And we're looking for a folder that contains the projects that are installed, the apps that are installed on the phone. And it's under data, so off the entry point or CD data a second time. And here we go. So here's all that stuff that is loaded on the phone, and that includes the SQLite package that we've just created. And if we look inside that folder, there's another folder that contains databases. So this is that file. Remember, we created the file name ourselves. We wrote this in our code, appdev android SQLite.db. So we're looking at the memory of the phone, and the memory of the phone is not the same as putting it on the desktop of the Windows machine. And the way that we do that is by using not the shell command, but there's a pull push command. So let's exit out of the shell, and we're going to use a different command. And if we say adb/?, we get all this help. And so what we're looking for is this command at the top of the list. And basically it says adb pull the file name on the remote to the path of the file here locally. Now the path is a really long path, and we have to type it perfectly. So here we go, adb pull, and then data/, and then we work our way into our project. So com.appdev. appdev android SQLite package, and then rather than using the \, which is really tempting under Microsoft, we have to keep using the /, which is the Unix way. So we're in the folder for the actual application, database says, and then the file name itself, android appdev SQLite.db. So that's the file that we're looking for, and if we hit enter, it'll bring it back into the current folder. And it looks like it was mistyped. So Android appdev is flip-flopped. It should be appdev android. There we go. So there's a file here, 315K file, and we just downloaded it locally. It's a .db file. So if we said dir start.db, here's that file that came from the memory of the phone, and now it's sitting inside of the Windows desktop. So now let's go get that from Firefox. So under Firefox, we have the SQLite Manager running, and we'll hit Database Connect. And through the desktop, we're looking for the SDK. And this is the folder that you'll find on all machines that have the developer environment for Android. So Platform Tools is the location where we put the file, the same folder as the command itself. So if we do a search for star.db, we'll find this right here, appdev SQLite. And there we go. So that's that record that we added from the application that we wrote. We added a record for the longitude, latitude, altitude, 123.1, 456.1, and 789.1. So that wraps up our section on how to connect to a SQLite database, how to fire off a raw SQL command, and how to pass content through the content values object in a way that under Microsoft Visual Studio we would have called this a command object working through ADO.NET.